Hello everyone, in this video we'll be discussing about electron dot structure of covalent compounds. So electron dot structure is also called as Lewis dot structure. So here we will be talking about in covalent compounds how the dot structures are represented. Now what is a covalent compound? A covalent compound which contains covalent bond. So a covalent bond is formed between two non-metals. Okay, by sharing their electrons between two non-metals, covalent bond has been formed. So we have certain steps to follow to write down the dot structure for covalent compounds. So for the given element, you should be knowing the atomic number, and followed by that you should know how to write down the electronical configuration, and then finally we have to find out what is the valence electron. So now we'll follow these steps and try to do the dot structure for the given examples. Okay, now let's take the first example, that is hydrogen atom. In the first example I have hydrogen atom. So H2, it's diatomic. So here if you see, we have two hydrogen atom. So now the atomic number for hydrogen is 1. Fine. So but then hydrogen, if you see, next to hydrogen, which is a noble gas we have, that is helium. So helium is having an atomic number of 2. So therefore the hydrogen is following a duplet rule, not an octet rule. So hydrogen wants to be stable like helium. Because next to hydrogen we have a noble gas which is known as helium. So it requires just one more electron to be satisfied and follow a duplet rule. So now as we know, each hydrogen already has having only one valence electron, and each hydrogen requires one more electron to be satisfied. Therefore hydrogen will share its electron with the neighboring hydrogen atom and they will form a bond like this. Okay, now we can also represent this as one single covalent bond between the two hydrogen atom. So there is a single covalent bond between them. So this is the dot structure for hydrogen. Now let's go with the next example, that is nitrogen. So in case of nitrogen, N2, we have two nitrogen atom. Okay, so now let's see the distribution of electron. So nitrogen atom atomic number is 7. So how is the distribution of electron taking place? 2, 5. So it is having a 5 valence electron in the outermost shell. So in order to follow the octet rule, it requires how many more electron? It requires 3 more electron to be stable. So now nitrogen, it is having 5 valence electron, right? So let's show the distribution of electron. 1, 2, 3, 4, 5. Similarly, next nitrogen also 1, 2, 3, 4, 5. Is that clear? So now each nitrogen already has 5 valence electron and each nitrogen requires 3 more electrons. Therefore this nitrogen will share its electron with the neighboring nitrogen such that they form a bond like this. So already 5 plus 3, 8 electrons, satisfied, octet rule. Again here also it is 5 plus 3, satisfied with octet rule. Therefore nitrogen has how many bonds? So they have triple bond between the two nitrogen atom, and these electrons are not involved in the bonding. They just act like a lone pair of electrons. So they are not involved in the bonding. So this is a dot structure for nitrogen. Now let's take the next example, that is oxygen. So that is O2. So now we will write down the two oxygen here. So oxygen atomic number is, as we know, it is 8. Distribution of electron, it is 2, 6. So it is having 6 valence electron. So in order to satisfy an octet rule, it requires how many more electron? It requires 2 more electron. So first let's write down the distribution of 6 electron in the oxygen atom. So 1, 2, 3, 4, 5, 6. So similarly 1, 2, 3, 4, 5, 6. And each oxygen requires 2 more electron. So they will form a bond like this. They will share its electron like this. So even this oxygen, so 6 plus 2, 8, 6 plus 2, 8. So now between the two oxygen atom, how many bonds do we have? So they form a double bond, and then these electrons are not involved in bonding. So they have lone pairs of electron. So this is a dot structure for oxygen. So next let's take methane. CH4, methane, CH4. So here if you see the structure, we have one carbon atom and we have 4 hydrogen atom in the terminals. So carbon atom, what is atomic number of carbon? So carbon atomic number is 6. Okay, so distribution of electron will be 2, 4. So K shell 2, L shell 4. So it has 4 electron, and carbon if you see, it requires 4 more electron to satisfy octet rule. And hydrogen, we already know it requires just 1 more electron. So each hydrogen is having atomic number 1 1, so 1 1 electron I will show. And carbon, as we know, it is 4, so we have to show with 4. So it's better you represent carbon's electron as some other symbol, and hydrogen you can show with a dot something, so that you have the variation between the carbon's electron and hydrogen's electron. So now each hydrogen is following a duplet rule, so we have to show the bonding like this, such that each hydrogen is getting 2 electron. Now just see carbon, it is already having 4 electron and it requires 4 more electrons. So the bonding in the carbon should be represented with a complete circle like this, which indicates it is having altogether 8 electrons, 1 2 3 4 5 6 7 8. So carbon is also satisfied with octet rule and hydrogen is also satisfied with duplet rule. Okay, is that clear? So now let's take one more example of C2H6. Okay, C2H6. So now we have 2 carbon atom and we have 6 hydrogen atom. So it is 1, 2, 3, 4, 5, 6. Same way hydrogen I will show with 1 single electron and carbon with 4 electrons. So 1, 2, 3, 4, 1, 2, 3, 4. And between the carbon and carbon there is one bond. Okay, and here there is one bond. So you have to make sure that each hydrogen is getting 2 electrons. So they follow the duplet rule. And now let's see, carbon should follow octet rule. Already it has 4, it requires 4 more. So you have to show one circle like this. This carbon is satisfied. Same way with this carbon also, already 4, it requires 4 more. So you have to show a circle like this. Okay, so this is the dot structure for C2H6. That is nothing but ethane. Now next we will take an example of chlorine atom. So in case of chlorine, very simple. So we have 2 chlorine, Cl2. So now 2 chlorine. What is the chlorine atomic number? So chlorine atomic number is 17. Distribution of electron 2, 8, 7. So 7 electrons it is having in the valence shell. So how many more it requires to satisfy its octet? It requires just 1 more. So 1, 2, 3, 4, 5, 6, 7. Okay, so similarly 1, 2, 3, 4, 5, 6, 7. Okay, so it is having 7 electron and it requires 1 more electron. So just one single bond will be formed between them. So like this the distribution of electron should be shown. So now between the 2 chlorine atom you will just have, chlorine atom, you will be just having one single bond between them. A single covalent bond is formed. Okay, now we will also take the next example, CO2, carbon dioxide. So how do we do carbon dioxide? Now let's see. So CO2, so first let's write down the structure. We'll have carbon in the center and at the corners we'll be having 2 oxygen atom, and between the carbon and oxygen we'll be having a double bond. So let's first write down the normal structure. So then after writing this, it will become easy for you to do the dot structure. So carbon already you know, atomic number is 6, distribution of electron 2, 4. Oxygen already known, atomic number is 8, distribution of electron will be 2, 6. So 6 electron, here 4 electron. Okay, so now let's see the dot structure. So carbon 1, 2, 3, 4. 4 valence electron, 4 electrons. Okay, so oxygen, how many electron it has? 6 electron. So 1, 2, 3, 4, 5, 6. Okay, so similarly this side also oxygen 1, 2, 3, 4, 5, 6. Fine. So now how is the sharing of electron taking place here? So now here oxygen, if you see, it is having 6 valence electron. It requires 2 more electron. So they will combine like this. Okay, now 6 plus 2 satisfied 8. Again similarly here also 6 plus 2, oxygen is satisfied. Now we have to satisfy even carbon. Carbon is having 4. It requires 4 more. So the bond will be formed like this. Is that clear? So now here they have 2 lone pair of electron in the oxygen atom. So this is the dot structure for CO2. So now let's see the last one, the dot structure of C3H6. So C3H6, actually if you do the structure, we have 3 carbon atom, and then one of the carbon atom will have a double bond, only then we will get C3H6. 1, 2, 3, 4, 5, and then 6. You can do this. So yeah, so 1, 2, 3, 4, 5, 1, 2, 3, 4. Yeah, so this is the structure. So we'll be doing the dot structure for this. Okay, so same way, carbon, I will write down the hydrogen here. Okay, now here this hydrogen is having 1, 1, 1 electrons. Okay, now this carbon, I will show the electron. 1, 2, 3, 4. Now 1, 2, 3, and then it will have 4 bond. So here also it is having 1, 2, 3, 4 bond. Okay, now here what is happening, there is single bond forming. Here one single bond, here one single bond. Okay, and here again there should be a single bond, and here there will be a double bond. Again there will be a single bond. Okay, now here also there will be a single bond. There is a single bond here also. Now you have to satisfy the carbon. So here it is 4 plus 4. So it will form a bond like this. So similarly next carbon also. So 1, 2, 3, 4, 5, 6, 7, 8. So there will be a bond formed like this. Now here this carbon 1, 2, 3, 4, 5, 6, 7, 8. So they will form a bond like this. This is how the sharing of electron takes place. So dot structure and the bond structure should look the same. So these are the examples that we have practiced in this video, the dot structures of covalent compounds. Okay, so right from hydrogen you can just look into it once. So you can look into this example also. Thank you so much.